In the beginning, there was stone. Human beings shaped found objects into powerful tools for hunting and agriculture. In the next era, humans used bronze and iron to create advanced tools. We plowed fields and built cities with complex metal implements. The Industrial Revolution gave us steel and concrete, towers that reached for the sky, cars that took us there, and ships that crossed the ocean. Chemical synthesis brought the world composites. We built jetliners, created life-saving medical devices, and reached the edges of our solar system. Semiconducting silicon sparked a digital revolution. We mapped the human genome, connected the world, and learned to adapt to changing environments. Now we stand at the crux of a new era, the age of biomaterials. A world where creating custom prostheses for medical and dental treatment is as normal as using a smartphone. SprintRay stands at the apex of this future, a future where destiny is practiced with unprecedented accuracy, precision, and strength. A future that begins today in this room, dreamed up by SprintRay, powered by you. Welcome to the biomaterial age.
Welcome to the stage, Amir Mansouri, co-founder and CEO.
All right. Welcome to the age of biomaterial. I'm Amir Mansouri, co-founder and CEO at SprintRay. Before we get started, I want to highlight one more time about the video that we just saw. Human beings' prosperity has always been directly related with how we've been mastering and shaping materials into our needs. We saw the caveman shaping stone into tools for hunting, for defending themselves, and that's what they differentiated creatures from us in the early ages of humankind. Today, we're not limited to stone and sticks. We have so much. This is going by itself. It's not supposed to. All right. So today, we're not limited to stone and stick. We have supercomputers, nuclear, advanced chemistry, and science in our disposal. And look what we have done. We have engineered material into parts that interact with biological systems. Hip joint, my favorite, cardiovascular stent, giving almost another life to us human beings. This is biomaterial. My most favorite of all, dental implants. We take it for granted, but you get hit something in your eye and you lose your eye forever. We take this for granted, but you lose a tooth. Then you have another one using biomaterial. You get another 20, 30 years out of it. My most favorite from the SprintRay ecosystem is just our Onyx resin. I think 20 years ago, this was a science fiction. 3D print, full arch, hybrids, upper and lower, full set of prosthetics in 25 minutes. That arguably is better than what we were born with. This is the journey of crown. Example of what I just shared. In the past century, crown was always the crown. What we evolved and made better over 1 century was how we make the crown. In the early 1900s, it was pressing metal. In the mid-1900s, but casting and PFM and metal. And then late 1900s, milling. And in 2024, we're 3D printing it. Again, crown has always been the crown. What changed was the way we're shaping this material to our needs. And that's, ladies and gentlemen, is the age of biomaterials. Our prosperity, our health span, and lifespan is directly linked in with how we innovate in this field. And we strongly believe dentistry will and can play a crucial role in this new era. Let me take you to 2027. This is downtown Los Angeles, our first ever office. SprintRay has 5 or 6 people, as you see in this picture. Still remember this room, red chair, accent walls are red, and we just came out of the PhD program working on a lot of lunar and Martian construction project with NASA. It was all exciting. And then started the company, 2016, 17 time. And we had one big decision to make. Do we want to focus in dentistry and only dentistry, or not? We want to be serving other markets. It was a tough decision. We had no clue what dentistry was. It was very uncertain. It was very uncomfortable. We were engineers, knowing nothing about dentistry. We made the decision. We went all in. And I'm sharing this story to tell you about the power of focus. Whatever we have built today is all because of that one decision we made in 2017 to become a dental-focused company. And the same focus took us the strategy and commitment to the workflow. We looked at things differently. We came outside of dentistry from engineering. We looked at the workflow, make it better, software, hardware, material, AI, and cloud systems working seamlessly to 3D print parts. 2017 was my first ever Chicago Midwinter. I walked the floor. We had a very small booth. We could only do models and castable resin for doing PFM crowns. That was it. Hard to believe. Printing a crown, full definitive crown, full arch, was a hallucination. I mean, today, SprintRay has more than 10 different applications that we developed in the past 5 years. And every one of them went through generation after generation. Just Onyx alone is in its 3rd generation in the past 3.5 years. And every year we made it better, better, and better. Today, we're challenged by some physics limitations. Limitations that getting on our way of forming the material into stronger resins, stronger crowns, stronger full arch. And we have to invent new ways. And that was the whole idea behind putting together the Biomaterial Innovation Lab. To mesh hardware, to mesh machinery with software, with materials to overcome these challenges. And to do one thing, or actually maybe 3 things: more indications, better indications, and stronger indications. It's one thing, but it's 3 things. And we're doing it by harvesting the power of software, hardware, and material. I'm going to repeat it. Hardware, software, and material should work together to form materials into the final prosthetics that we need in dentistry. People who are serious about dental 3D printing should make their own hardware and software and materials, all 3. It's impossible to do it if you just want to be focused on one of them. And SprintRay is the only one who's doing it with that vision. For the rest of the night, we'll be showing you the vision of Biomaterial Innovation Lab and what our team has been up to and what we've been thinking about the future. Dr. Sam Barjeste will talk about the science behind Biomaterial Innovation Lab. Same, my co-founder talks about the machinery enabling these innovations, and Dr. Steven Shao talks about the latest products coming out of this lab. I pass it to Hassan. Today, our journey brought us to the point that we're inventing to invent. We're not just creating something better, we're creating something new. And that's the introduction of Biomaterial Innovation Lab.
We are responsible for developing products that's used in dentistry, in particular digital dentistry. Within the last 5 years, we've developed multiple products, including surgical guide, night guards, full arches, crown, bridge, and the variety of products that is serving our patients and our stakeholders, which is doctors.
Because of the advancements in hardware and advancements in software, now we have an open field to innovate in the materials. And the hardware and software are enabling this biomaterial innovation to go to the extents that has never been done before.
Biomaterial Innovation Lab is the forefront of advancing digital dentistry. We can actually tackle new challenges that's right now currently with the existing technology, it's not possible. We've been working on a combination of hardware, software, and material. We can create innovative product that right now we can't think of.
Quality at SprintRay is the top priority. We want to deliver products with high quality standards so that when the user uses the product, they are reproducible and repeatable.
For me, on a day-to-day basis, working with amazing group of chemists, engineers, and when I see their passion and their excitement in developing products, it makes me more excited to be there and be part of that journey that we are together.
At SprintRay, everything starts with the customer. Hardware product and resin products all start from the customer POC. We let the materials lead our innovation, and hardware acts as a servant to the materials.
We communicate with our materials team and do everything we can from their hardware wish list so that our next generation of hardware is future-proof for the materials.
Some of the technological innovations that allow us to print with the next generation Onyx Tough 2, Night Guard 2, and Apex material include higher chamber temperature and also lower wavelength. This allows us to achieve the optimal shade consistency and mechanical properties in the same amount of time or even less time.
So the process of developing resins is very meticulous work, and it takes sometimes hundreds of formulations to lock a single shade. And when you have, 8 shades in one product portfolio, you might run thousands of formulations just to lock just the shade alone.
We ensure that the product that was developed at R&D now has been fully transferred, and we are capable of repeating and delivering the same product at larger scale.
One of the great challenges that we have overcome is the thermal management in such a compact product. We knew that for the next generation curing products such as the nano curer, we wanted a smaller product that's more suitable to be used in office and chairside.
We're creating a new platform of innovation that enable us to invent and innovate more.
It's our job as hardware engineers, as software engineers, to come up with solutions and innovations in order to bring that renaissance to materials.
When we create a platform technology, we want to make sure we build over it and create new products. I'm very excited that the roadmap and the future is very bright for us.
Welcome to the stage, Ehsan Barjeste, head of SprintRay Biomaterial Innovation Lab.
Sure. Good evening, everybody. Oh, that's going too fast. Okay, so I want to talk about the mission of Biomaterial Innovation Lab. And Biomaterial Innovation Lab, as the name says, we are going to innovate solutions. But for why? Look at the picture, the smile. We want to improve the quality of life and the health of our patients, right? At the end of the day, whatever we innovate, it has to have a meaning in life, right? So I'm not a dentist, I'm not a doctor. I'm a PhD in material science, and before joining SprintRay, over 15 years, I worked in aerospace industry. I formulate products for aerospace that, as you guys know, you need the highest performance and safety for the products that you develop. Within the past 5-6 years, after I joined SprintRay, I got all of the good practices with me to SprintRay, right? And I wanted with the team to innovate, right? We were so fortunate that SprintRay or the company invested in us, so we were able to hire a lot of top-notch talents. We have over 100 years of combined experience in UV curing formulations, in dental product formulations. And then if you look at the journey of how we innovate, right, we have talents, right? But then when we start the formulation, sometimes we develop up to 100 different formulations, and we print, we test, right, to have a leading candidate. And then after we have a leading candidate, we send it through the external testing and validations to make sure what we deliver to you guys are the top-notch product. Now, how long does it take? Sometimes it takes up to 2 years, right? From the inception of an idea all the way to formulation, verification, validation, regulatory, manufacturing, right? So it is not an easy process, but definitely it's very fun. So in Biomaterial Innovation Lab, when we have an idea, it's always about you have multiple competing dimensions, right? So you want to have a product that's really stiff. For instance, when you look at restoratives, you want to have a very stiff materials. But the current chemistry, monomers, oligomers, or polymers cannot render that type of a stiffness. Then you start adding ceramics to it. Suddenly you start losing the opacity, or you start losing translucency, or opacity increases, right? You add fillers to your resin, then the viscosity goes up, and we cannot 3D print, right? This is another dimension that we ought to look for. And of course, biocompatibilities. A lot of materials off the shelf that we purchase, you cannot use in dental field, because at the end of the day, the product has to be biocompatible. So in a day-to-day basis, in order for us to innovate, we have to look at all these dimensions and figure out the most optimum values to define the product. Now, I want to now put my professor hat on. So I've been professor in material science for almost 10 years. I always like to geek it out and tell you guys what's in a product, right? There are, every dental material that we develop has 4 constituents. Like it has oligomers, right? We usually use acrylates, methacrylates base, and then the oligomers are the backbone of any products that we develop. Then the second constituent is usually the monomers. You want to make sure you have a viscosity that you can print materials. You want to make sure that you have a good adhesion. You want to make sure you have a good cure speed, right? So therefore, the monomers are the one that renders those properties. The most important ones recently is additives. You want to have a specific shade. You want to have, let's say, a crown that you really require a lot of stiff materials to be in your formulation, right? Therefore, additives are the third constituent. And then the photoinitiators, the kicker. Without that, no solidification happens. You really need to have photoinitiators, even in a small percentage, so you're able to make a 3D shape parts. So all those constituents, you have to have innovation in those to create a technology. Late 2022, we developed a platform technology that we had inventions in both chemistry and the fillers, right? So the combination of these 2 inventions, it gave us the nanofusion. And out of nanofusion, we created the indications like dentures, full arches like onyx tough materials, which I'll explain a little bit later. But what is nanofusion, right? I mentioned we have fillers, which we engineer those fillers. We work on the size, shape, form, surface of those fillers, so that when they're blended into your polymer, it's like a dissolve or fuse into it, right? They don't agglomerate like the picture to the left. No one wants the material with the picture to the left. You always want to have a uniformly distributed fillers in your matrix that you're able to actually make a part that lasts the longest, right? So this is a picture that I like. So the effect of temperature is extremely important. In nanofusion, I mentioned to you guys as we invent chemistry, right? So at body temperature, at this picture is around 37 C. But often you drink hot liquids, tea, water, right? And as you can see, we have a competitor product that's very well known. And as the temperature goes up, the stiffness goes down and the material becomes soft. What happens if the material becomes soft? When you're chewing something, it could break, right? So, but look at the nanofusion. Basically, the invention that we have with the chemistry, it helps us retain the properties at high temperatures. This is another one from nanofusion that I want to tell you guys is we had a hot bath, right? We print 2 bars. We put weights on it. We raise the temperature to body temperature, which is 37 degrees C, and we let it sit. We monitor the deformation. Who wants the product to the left? It deforms, and sometimes it permanently deforms. You're going to lose the accuracy, comfort, and if it breaks, it's going to damage or it's going to hurt the patients, right? But we're so proud that with the nanofusion technology, we were able to retain properties at the body environment, right? So before I give you guys some examples of the products that came out of nanofusion, when we do the innovation, we actually test what matters in dental. Strength, wear, toughness, stain, accuracy, shade. These are all important to you guys because you guys want to deliver the best and the best products to your patients, right? So we internally test all these, right? But we're not satisfied there, right? We always want an independent study, a third party to test it for us. After we test it, we send it to university, and believe me, these universities are not easy. They're very tough, right? They give us a lot of sometimes harsh feedback. Then it's fine, we get it, we start redevelop, and then send them again. And therefore, this is a healthy cycle to give you guys the best products available. Now, I want to give you guys one thing that we're very proud of, right? This is the Apex resin. And look how natural and beautiful it is. We're very proud of the Apex material. It gives you the performance that you want. It gives you the translucency that you want. So for the denture, for instance, you need to have a right strength. But often, you don't need a strength at room temperature because people have it on. You really need to measure strength in water at the body environment, right? So take a moment to look at the Apex strength, flexural strength, for instance, and compare it with the traditional materials, right? It exceeds the traditional materials, right? And look at the 2 competitors that we had, right? These are the side-by-side comparison. If you don't do a side-by-side comparison, you may see data all over the place. But you can see actually we surpassed the traditional materials. And then wear. We want less wear, right? The wear basically tells you the lifetime of your product. You don't want the product to lose weight, to lose volume, right? So the less, the better. Look at the PMMA base and teeth. It was done by Loma Linda University. The previous data also was done by Loma Linda University. And look at the volume loss that we have. Again, it's less than the traditional materials, which everyone uses, right? So now look at the full arch. Another product came out of the nanofusion. There are pins there, right? There are pins that goes to a hole. It's either all on 4 or all on 6. Those holes can, under load, can create fractures. Therefore, for the full arch, fracture toughness is extremely important, right? How did we address the fracture toughness in the nanofusion, right? If you use the micron-sized particles, often what happens is, if you consider the notch is the hole in your full arch, the crack can pass through without any resistance, right? So to the right side is a nanofusion with the similar amount of fillers, but very small one, and we surface engineer so it blends into your matrix. What happened is the crack has to go and pass through all these small particles. If you want to do it, you spend energy, and therefore your fracture toughness improves, right, in a very scientific term. So look at the data that we got. So the dent in an animal, look at the fracture toughness, or K1C. And to the left is Onyx Tough. We have lithium disilicate and some PMMA, but guys, take a moment, right? This is the 3D printing materials. We already surpassed the traditional materials and also enamel and dentin. This is a big deal, right? So what's important for most of you is the shade. We spend a lot of times in R&D to match the shade. We spend it, look at the Onyx. I remember for the bleach, to get to the bleach or A1, we actually had over 56, 57 iterations to get to the right shade. So we spend time to make sure what you get is exactly what the standard asks you. So now the translucency. You want to have a natural look, so you do want to have translucency, right? Nanofusion, these nano-sized particles was fused into your matrix. What happened to the left is if you have a large particles, right, when the light shines, they start scattering the light. Therefore, the part is not translucent. In nanofusion, these small particles doesn't scatter the light, so you get the translucency that you would desire. And look at the left one, which was micron size, and look at the right one, which is the nanofusion. Look at another picture of the process of the denture, right? So this is one experimental materials that I'm showing you guys. It has over 50% ceramics in it, over 50%. Look at the translucency of the product. It's a veneer that one of our doctors worked with us to print it, and this is what's possible. Look at the polychromatic restorative. This was printed with the same material, but you can see the shade differences, right? And if you manage to have a right translucency. And then the stain, right? That beautiful smile that I show you, we want to have the same quality of a smile, right, after a year or 2 years, right? So the way we do is we measure the color of the material after many days. In this study, Loma Linda did after 28 days, right? And then you expose it in the first graph in tea, and then in grape juice, right? They couldn't have wine on campus, so they chose grape juice to do it. So look at the stain of the apex teeth and base and compare it to PMMA, base and teeth. The less, the better, right? The less meaning that the color change is less. So accuracy. You want comfort for your patient. When you have a base and teeth, you want to have an accurate material, right? So in R&D, what we do is we scan the formulations and the workflow. The left one is, it's not an optimized workflow. The right one is the same device, but when we optimize it, right? And the green color meaning that it is accurate, and the red meaning that means that it's not. So in R&D, whatever we do, we make sure we get the accuracy that we want. And this is a video that shows in one click, and actually the product is accurate as we desire. So what's coming? What's coming is the retainer. The direct retainer is coming soon. Crown solutions, which you guys are going to hear from next speakers. Sports card is coming, right? New denture solutions that's in our workflow. The new dental models, very accurate, very fast dental models. Stain and glaze and gum characterization kits. These are the products that's coming in near future, and you'll get an access to it. So in all these innovation, what do? We have three strategies, right? One is to work on the base chemistry. We have good formulation experience. We want to work with our partners to create new oligomers, new monomers that are specifically used for dental. Then for restoratives, you really need fillers. We want to engineer fillers more than what it is. We want to find the best filler that can provide the highest strength and stiffness for your restorative. Ultimately, you want to improve those properties, right, to be as close to the Emax or lithium disilicate. And then we're blessed to be vertically integrated. We have hardware, we have software, and we have resin. So hardware can be enablers for us, right? For instance, Hossein is going to talk about some of innovations that we had in hardware that using the same chemistry, you could print it faster. So before I give it to Hossein, I want to show you guys one picture of, it's a cabinet of the engineers, one of the engineers that I have, and during the developments of the denture. So this is what didn't work, and ultimately what you saw is what worked. So I want to end it here and give it to Hossein to talk about the hardware innovations.
Welcome to the stage, Hossein Basir, co-founder and chief product officer.
Welcome, welcome. How's everybody doing so far? So I'm a designer, and this room is not balanced, so it's really making me uncomfortable. Please have a seat. Please, whoever is standing up, please have a seat. Get comfortable. The other thing is, Essam was telling me that our slides are super nerdy. I was like, yes. So are you guys ready to put sexy back into nerdy? All right, let's do it. All right. I want to emphasize on the point that Amir made, and Ehsan made it again. People who have true commitment to this make all three pieces. It's not just one. It's all three, and it's an interplay of software, hardware, and materials. And the SprintRay is committed to that. And we have been shown that. We have a great track record of doing that every day, every month, every year. You have seen the examples of that coming out all the time. But let's talk about enabling biomaterials. How do we do that? What do we do today? We have built an ecosystem that is cloud connected, consisting of a 3D printer, Pro S. You have Pro 95S, 55S in your offices. The Pro Wash S, doing the link between the printer and the Cure, and Pro Cure 2. All these pieces working together to bring it together as a dental appliance that is class 1, class 2, ready to go. Today, you can print almost anything with our 3D printers and our material portfolio. But what can we do better? How can we improve this? What is next? What are the opportunities? If we talk about chairside 3D printing, if you want to deliver it on the same day, you want print speed. And we are known for speed. Efficient use of resin. These biomaterials are expensive, they're precious. You want to save them as much as you can. You want to print just enough. With that, we introduced, and we are reintroducing them today, the Pro S, Arch Kit, and Crown Kit. So these systems are helping Pro S to do what we just talked about. Print faster, print more efficient, and enable the future of biomaterials. So how do these things work? Well, first of all, they're made of a build platform and a resin tank. And these two different kits have their own build platforms and resin tanks. And there's a good reason for that. When you want to deliver a crown, you want it faster. You want to also save more resin. When you want to print a hybrid denture, you need more resin. There's more build volume required for that. So that's why there's two of them. Now, what's special about the build platform in these things? Well, first of all, these fillers, these oligomers, monomers, everything that Hassan just talked about, they are corrosive. They eat through the aluminum platforms that we have. And aluminum is one of the best materials you can use for that build platform. So what we do is that we hard anodize them. We make them even stronger. It becomes as strong as a stainless steel without the heft of a stainless steel. They're chipped. They have memory. They remember what happened. When you put them into the printer detects them automatically. They also come with powerful built-in heaters. Why? Any guesses? Viscosity. Hassan is packing as much as he can into the resin, so it gets thicker and thicker. To print it fast, you have to lower the viscosity. Next up, resin tanks. What is so special about resin tanks? Why did we even do this? A lot of people end up at the platform only. You've seen examples of that. Well, we built a kit. The reason for that is that in order to really, really control the volume of resin, which helps the print speed, you have to make the tank smaller. You have to make the amount of resin less and less, based off of the application, obviously. That's why we have arch kit and crown kit. They're also chipped, so it becomes much easier to remember what was in it. The printer automatically detects those and puts itself into the mode. In order to even make it easier for you guys, we built in spouts into them so you can switch between resins if you have to. We don't recommend that, but if you want to do it, it's there. The other piece of this is software. Software on the cloud that we have built. Raver Cloud helps with automatic nesting, and it detects all the kits. The printer talks back to the cloud. It tells it, hey, I have this kit installed. So automatically everything just kicks in and does it for that particular kit. And the other piece of software sits on the printer itself, which is where it detects the kit. It tells the cloud software that I have this. Now, we got up to here, and I think you guys have heard about crown kit before, so that is how we deliver less than 10 minutes crowns. Those of you who have used this, you know it's a reality these days. And next up with arch kit, we can go up to 2 times faster than before. Hybrid dentures in 20 to 25 minutes, depending on how big the arch is. 15 minutes on models. This is gained speed for delivering these biomaterials at chairside level. Night guards, super quick. Dentures used to be 2 hours. Now it's less than an hour. So that is ProS, Arch Kit, and Crown Kit, enabling the next gen of our materials, powerful and feature-proof, helping the printer to actually have another few years ahead of it. And also efficiency in use of resin, which is very important. They're available today to purchase. If you have a ProS, they're all compatible. Now next, enhancing biomaterials. What does that mean? How do we do that? So if you guys have been printing night guards, it's one of those applications that has a lot of use these days. We kind of brought that into the market in a way that nobody has ever done before. But if you've done this process before, you know that there is polishing involved. There's about 5 to 10 minutes of polishing depending on your skill set and how many you're doing. Essentially, if you want to do multiple guards, if it's an upper and lower for any purpose, then multiply that by the number of guards that you have to do. So this is not SprintRay. This doesn't make Amir Mansouri happy. He's sitting there. He's not happy about 10 minutes of polishing. And a wise man said, which he's also sitting here, that the best polish is no polish. Why do we even have to do this? Can we get away without it? So with that, we're introducing optical polish, which is straight polished appliances straight out of the printer. How does this work? Well, let's go through one of the standard finishes. You've seen this before. I hope you all are using our products. So you've seen how frosty the appliance comes out, especially night guards. You ready for this? Yeah. Look at how it will come out next. This is the magic of optical polish. And I know this is a rendering, but we'll get to pictures about that. You will see it. So how does this work? How do we make everybody be able to deliver this kind of appliance? Magic of optical polish is in the resin tank. We have remastered the stack inside, the film, the glass, and everything else that goes into that to just deliver that via using just resin tank. And because of that, it's all reverse compatible. It's a very easy upgrade for everybody. Almost everybody can buy this at no cost. Comes as a standard soon. And here's how it looks in real life. See, the rendering wasn't that far off. It's the same thing. All you need to do is maybe polish a few minutes on those support nibs, and you're done. This is a true painkiller for people who have been going through polishing a lot of these night guards on a daily basis. Here's optical polish again. Again, straight polished appliances straight out of the printer. It's a time saver, enables the next gen biomaterials like what we just announced, Night Guard Flex 2.0, which also comes in clear. I think we have a few samples here that we'll show you later, that the clarity is just outstanding. These tanks are going to be available in April 2024. Next up, maximizing biomaterials. So we talked about enabling, we talked about enhancing, and now we get into maximizing them. How do we do that? What does that even mean? What comes to mind? Mechanical properties, biocompatibility, strength, all those things, right? Our existing machine, Procure 2, is one of the best machines in the market, one of the fastest. When it came out, everybody just lost their shit. It's like, how much faster can you go with this, right? But then again, in true SprintRay fashion, we don't stop there. It never stops. We never stop improving. So what are the opportunities? Definitely improving the curing environment. Cure them faster. Size to performance ratio. We understand that dental offices are running out of space. We ask them to put more equipment into the offices, and everything is just like bulky and big, right? And also future-proofing for biomaterials. That means any material we're going to release in the following years is going to be compatible with this machine. That's the goal that we have. With that, we're introducing the NanoCure, the next generation of hardware for biomaterials innovation. If you have been to our booth today, you may have seen it, but we have also one here obstructed by this bottle. We move the bottle out. And yes, it's that small, and you can actually hold it with one hand. But beyond the surface, this is the machine to enable the future of biomaterial science. This is where we are actually hitting this ball, we're kicking this ball 10 years ahead with this kind of hardware. We are not designing it just for today, it's for future. How do we do that? We built in dual wavelength system into this. It's up to 3 times faster than Procure 2. Can you even imagine that? Procure 2 was super fast. Now this is like whatever, ultra fast. Has a dedicated heater. That's very important for getting the biomaterials to perform the way they should. And it's nitrogen free. Every time, whoever does zig, we do zag. We don't want to follow anybody. Nitrogen-free is one of those things that we committed to it. Vacuum-free and nitrogen-free. There's none of that in this. Who wants to buy a small machine and then hook it up to a big machine? Nobody. They're really good at that. All right. So cure times. I guess everybody's question is like, well, how fast is this? Before we get to that, let me tell you how we get that fast. What we do is that the first wavelength kicks in automatically. You don't do anything. The machine detects. It says, OK, this resin, let's do 365. We do surface curing. We close the perimeter. This is where the tackiness used to come from, remember? This is gone now. Next, we kick in 385 and then heat. Then we penetrate the depth of the model and we cure it to 100%. That's how we gain peak performance along with biocompatibility. And here are the cure times. 2 minutes on dental models. Occlusal guards used to be 8-7 minutes. Now it's 4 minutes. Crowns with crown kit. If you deliver a crown that fast, chair side. Apex dentures, this used to take a lot of time. Now it's 15 minutes. Huge gains in terms of speed of delivery. In addition to that, again, it's 50% less footprint than ProCure 2, and it's silent. All of this happens quiet. If you have a ProCure 2, it's a lot of power. It kicks in a lot of fans. This thing, you don't hear it. Actually, we had to build in speakers for this, so it will chime when it's done, so you won't forget it. Super silent. And that is a high-performance curing system called NanoCure. And it's available to purchase today. And you guys should be expecting a lot of nanofied stuff from us soon. This is the beginning of that transition. Okay. Once again, we made something that was super fast, even faster, where people could not even imagine that. We made it the most versatile ecosystem in dentistry, with all the resins coming out of Biomaterial Innovation Lab, combined with the hardware that is designed and engineered for what Ehsan and his team is working on. We marry the chemistry and hardware and software together. And this really is, we live in this, I call it crazy era. It's the renaissance of dentistry. Everything is changing super fast to the point that a lot of people are uncomfortable. They're like, does this even work? Well, we have proved year after year, product after product, that yes, it works. But you know what? I think you've heard enough from the nerds. Now let's go to the clinical director and hear from the clinical people, not just the nerds. And with that, I'm going to pass it to Dr. Stephen Shao.
Welcome to the stage, Stephen Shao, Clinical Director of SprintRay Biomaterial Innovation Lab.
You guys called it. Good evening, everyone. Thank you, everyone, for being here. This is my first time in Chicago. I actually packed my winter coat, my wool jacket and everything, and it's raining cats and dogs in Los Angeles, and I arrived at Gotham, and it's beautiful out here. So to answer those in the audience and also to answer Hossein, yes, I'm probably the biggest nerd here. You have heard from 3 speakers before us. Amir, whose graduating engineering thesis was how to 3D print a base on the moon using moon soil. We have Ehsan, who worked in the aerospace engineering for a long time, and we have Hossein, who also worked on the moon project and is a senior designer. And you have heard them speak for the last half an hour on a subject related to dentistry. And I'm the clinical director for SprintRay, and I spend most of my spare time studying design, engineering, and aerospace, and my dream is to actually go to space one day, so it's ironic. When it comes to what does the clinical director do at SprintRay and what my duty is, I believe it's really simple as this. My job is to take all that engineering, all the product, and then merge it together to clinical dentistry and how everything makes sense. And how does everything make sense? I always start my presentation with this, the circle of paradigm. This is applicable in every single industry, and yes, I saw that from an engineering textbook, not from a dental textbook. Out of the 3 circles that you see in front of you, speed, cost, and quality, at any given time, we always have to make a compromise. You can only ever pick 2 out of the 3 in any standard industry, with any fabrication, with any product. If you want something that is very fast and very cost effective, likely the quality is going to decline. Think McDonald's. If you want something that is very high quality and also very fast, you'll likely be very expensive, like a Porsche. There's always a compromise or a give or take. When we trade one aspect of these paradigm with another, we're not really moving vertically. We're moving horizontally. We're not expanding the market. We're not really innovating. A true innovation is meant to bring about an expansion of the paradigm circle. We want to do something faster. We want to do something more cost-effective. We want to do something better. And today, we want to make everything stronger. How do we do that? And how do we bring about the digital revolution into dentistry? And to reiterate what everyone else has said before me, if you're serious about 3D printing in dentistry, you make everything yourself. It's not just the hardware and the software and the material. It's also clinical utility, user feedback. It's also AI. It's also design. It's also making sure we get the patient satisfaction. We make sure that our products and our innovations make us better dentists and then give our patients the highest quality products available. My official position at SprintRay is the Clinical Director for Biomaterial Innovation Lab. So I align myself firmly with the R&D team, like those speakers before us. I believe my duty is to build a bridge between clinical dentistry from my office to the SprintRay Biomaterial Innovation Lab. And it doesn't matter how many times I have to drive back and forth. It doesn't matter how little time I have after a hard day of work. If something needs to be done, the hardworking engineers and chemists from the Biomaterial Innovation Lab, they'll just drive to my office, get an x-ray, get my feedback and color, and drive back. If it's necessary for me to evaluate a new resin, I will tirelessly drive over to the resin engineering lab, no matter the LA traffic, no matter how long it takes to get there. The Biomaterial Innovation Lab is 6 minutes away from my office. I can ride there on bicycle. What do we do here? What does SprintRay do? And a lot of people are out there at the trade show today. You look at all these companies, you saw all these new product launches. SprintRay is not a company that sells new products. We're a company that offers innovative clinical solutions. We're not here to replace an old technology. We're not here to replace alginate and stone. We're here to advance dentistry. We're here to advance material science. Going back to the paradigm circle, we want something that is better, faster, and more cost-effective. What we do is how do we create solutions that arose clinically. My collaboration with SprintRay started back in 2017. From 2017 until now, a lot of the innovation that you see here, they were designed, they were tested in my clinical setting. The size of the printer fits on my countertop. We have to make sure of that. The material that we print, it has to work. Case in point, when we come out with a new material like the ceramic crown, how do we test it clinically? How do we test it clinically on a beta stage? Do we do it on our patients? Who do we do it on? Well, the answer is simple. If you want to find out whether or not ceramic crown actually works in vitro, you have to test it on live patients. But what kind of patient do we use? Well, the patients that we use for the live clinical study for the ceramic crown sits on the first row right over here. The president of SprintRay, the CEO, the head engineer, and the head of material design. So these are some of the very first people to ever have the 3D printed resin crowns and partial restorations inside their mouth. When we talk about clinical solution, Hossein alluded earlier on the development of the crown kit and the arch kit. This was a painstaking task that took us approximately 1.5 years to perfect. While Hossein described all the hardware detail, the software detail, on how we get to print so fast, literally what we did was we're able to print a crown 3 times faster within the last 18 months. We're able to cure things faster by a factor of 6 within the last 2 years. These did not come about because the geeks and the nerds in the engineering team decided to tinker to see how fast they can build this machine. Right? We're not talking about Honda Civic with triple turbos on top of it and nitro. Let's see how fast it goes. The reason why the project originated was because, clinically speaking, in order for us to have a same-day dentistry done, whether it be inlay, whether it be onlay, whether it be immediate partial, whether it be aligners, it needs to be done now. It needs to be done not this week, not just today, but same visit and same appointment. Today in my office at Sunrise Dental Center, we have tested all of these materials to nauseam. What we do is I have been a CEREC user for over 16 years. Our office has always had CAD/CAM. My patients always expect same-day delivery. So from 2021 until 2023, we have cut our time for fabrication in half, if not more. In my journey with a chairside mill company, I can't say its name, but over the last 16 years, through 3 to 4 different iterations of the product, the fabrication of chairside crown has been hastened by approximately 50%. So it's 50% faster today to mill a CNC crown chairside than it was 16 years ago. Now imagine that. In 3D printing, within the last 12 months alone, we're printing twice as fast. We're curing more than twice as fast. And now we can design a crown with AI within minutes. No software, no mesh mixer, no exocad, nothing. All of these innovations come from clinical necessities. This is what I mean that SprintRay is not out here to sell a product. We're here to offer a clinically tested solution. Immediate partial after a surgical placement, crowns, bridges, inlays, onlays, partial restorations, everything in my office are done the same visit today. Coming back to the circle of paradigm, oftentimes we hear, well, this new thing will improve your clinical efficiency. This new product will improve your clinical efficiency. We're scientists. How do we quantifiably evaluate how much efficiency do we actually gain? So being an econ minor, and being an aspiring engineer, I came out with this formula. Can we define efficiency by multiplying speed with quality and divided by cost? Everything else being the same, if something is half the cost, it's twice as efficient. If we can print something 5 times faster versus sending out to a laboratory, can we claim that we're 5 times more efficient? And the answer is yes, we can. In clinical dentistry today, if you have a patient that requires an extraction, how long would it take to get an immediate partial denture back for an old lady that's going to his son's wedding in 2 days? Is that a possibility? Is it going to take 1 week? Is it going to take 2 weeks? It's over 500 hours in a week. In my office, we expect to deliver it within 2 to 3 hours. If you have a patient that wants to start on a aligner service, today, they're willing to pay for it, they're ready to go, they have done their homework, and they want to start a liner. How long does it take from the time that we scan these cases, submit it to company A or submit it to company B, until the first tray is returned to the office, and we can place it in the patient's mouth? 3 weeks? In my office, when a patient agrees to the treatment plan for an aligner service, the first tray is delivered within 3 hours. And if we're not too busy, 2 hours. Today, we can operate at a speed that's 100 times better, 100 times faster than sending anything out. We can operate at a cost that's less than 1/10 of the laboratory bill that will cost us. So in terms of the efficiency, we're already 1,000 times better. We can no longer compare the level of efficiency by pure numbers. So we use the term that I like to call in engineering the orders of magnitude. The order of magnitude is how many zero do you put behind to demonstrate how much more efficiency we gain by doing this. And the last we calculated it for most application in dentistry, 20 to 50,000 times. And that is achievable today. This is what we do in a clinical setting in my office on a day-to-day basis. I'm still a full-time dentist, believe it or not. I still work 3 to 4 days a week, and then I part-time over at SprintRay to learn how to be an engineer, and material scientist, and a designer. I like to point to the print that I have designed myself via my computer graphic design days. This is what I like to call a molar resolution benchmark. And what it's meant to demonstrate is quantitatively describe to you how much detail is lost when you fabricate a given prosthesis. So imagine if I want to CNC mill a crown today. So if I have a tooth number 14 that needs a crown, and I do a pre-scan on it, and then I prep the tooth structure, scan it again, if I were to put this into my milling machine, what does that end result crown look like if I were to mill on an Emax? The number at the bottom, that percentage, is a demonstration from a computer graphic angle how much detail is actually lost. The bottom of the print is what the prosthesis looks like or what the crown looks like. The top demonstrates to you how many voxel, which is the actual three-dimensional resolution that your print has. So in my clinical milling machine, and I have an in-lab, I would argue that my crown looks something like the 3%, anywhere between the 1% of the 3% mark. And we always see this. And we always say, well, sure, it doesn't look that good, but it's a molar and it's good enough. And I like to make this joke, but it's not really a joke. Can you imagine walking into your neighborhood strip mall? There's a brand new mall that's opened up in your suburb. You walk over there, and there's a fancy new dental office with a big sign outside. And the sign says, good enough dentistry. Is that something that we want? And then on the next plaza, there's another office. I have a CNC mill, and they're very proud of it. And you will drive up to it and go, well, good enough dentistry is probably not where I want to go. So let's go to this new place. And this new place is a fancy casted aluminum sign outside that's illuminated. And it says, no one sees the molar anatomy anyways. Is that what we want to do? Is that what we aspire to do as dentists? Well, what can a 3D printer do? Well, that print over there was printed on a SprintRay Pro 95S, not even the 55. The full resolution at 100% can be counted down to the pixels. If you take a microscope and look at it, you'll be able to see the secondary anatomy on those grooves. We can reproduce that today. That print was made over 2 years ago. In the 28 years of evolution in CNC mill, why can't we get anything similar to that? Have we hit a plateau? Or are we as dentists and the dental companies, other dental company, not asking themselves to push enough? This is the quality of the future of 3D printing in dentistry and CAD/CAM in dentistry. Again, we're here not to push a product, but we're here to offer a clinical solution that is relevant on a day-to-day basis. This is something that Maggie designed for us. Every single clinical aesthetic case will go through 2 weeks of trying. So what you see here is 6-unit anterior veneer or 3/4 veneer preps. So we always 3D print wax out for our patients. We do it the same day. Intraoral scan, face scan. We use whatever software necessary, do the full wax out, print it out. Allow the patient to pick the before and after, option A, option B. Before we even prep the patient, we'll print the snap-on smile. Again, same visit. Takes approximately 15 minutes or so to do so. We actually do it for fun. My daughter came home after school, and then she's into K-pop. She wanted to get a set of adult veneers. She's 10 years old. How much effort does it take to actually scan pediatric teeth, to do a full wax out, to then print a snap-on smile for them? Well, in my case, it was after work. It took us half an hour to get it done. So yes, my 10-year-old can have full mouth veneer so she can take a fancy picture on her I don't know if it's TikTok or Instagram. I'm not sure what kids use these days. I'm too old. Since 2018, SprintRay has been a leader in biomaterial engineering. To this day, it's one of the only company in the industry that makes everything themselves. From the AI, from the software, from the hardware, from the cure to the wash to the platform, every single piece of technology is manufactured in-house. I'm a big aerospace fan. If you go to Hawthorne, California, and walk into the SpaceX headquarters, it's going to blow your mind. And the reason is because, unlike the Apollo program and the Space Shuttle program, you can see every component of the Falcon 9 rocket being built right there. From the rocket engine to the housing, from the fairing, from the Crew Dragon capsule, everything is done in-house. This is why they are able to evolve so quickly. So where does that leave us? Of all these materials out there, most of them are best in the market. Best accuracy, most biocompatible. The strongest material, the first to the market. We're able to do this, again, through the first principle. Vertical integration of everything is one of the hardest things to do because it is the hard work that we put in there that allows us the flexibility later. The greatest strength of SprintRay is not the best marketing, it's not the best sales team, it's not even the best engineering team, even though we have all that. The greatest strength of SprintRay is a rate of innovation and rate of technical evolution. It doesn't matter what the competitors do, we'll always catch up to them and respond faster than they can. STF2, one of our newest resin, highly acclaimed, the first and the only FDA-cleared full arch restoration material. I was at the Invista Summit last weekend, and nearly every single full arch dentist in the country right now, or in the world right now, is either using this product or is eyeing this product. Their ability to design and print a full arch prosthesis same day after the implant placement completely revolutionized the way that full arch dentistry is done today. And this is only one industry and one resin. What else can we do? What other innovation can we evolve to bring about the future of dentistry? Here are some of all the beautiful smiles that are done mostly the same day. As an additional benefit, when you print a full arch, or when you 3D print any prosthesis, in fact, in your dental office, whether it be splint, whether it be crown, it can be inlay, onlay, it could be a full arch, it could be a partial denture, we always print two. And the reason is because it doesn't take any additional effort. It doesn't really cost that much more. It's the same time. It's the same effort. You always have a spare, no matter what. Where else in dentistry can we do that? When was the last time that we sent a case out to a laboratory to get a 3-unit zirconia bridge made, and we just check on the little box that goes, why don't you just make me another? Say, just in case. Just in case the patient loses it, I would like to order 2 of them. That's not what we do, but is that something that we should do? Is that something that is beneficial for the patients? When a patient orders a splint in my office, they get 2 of them. I don't charge them additional. It's patient service. And again, this is not about saving money on printing your splint in-house. This is not about saving money by printing your full arch in-house. At the end of the day, as a clinical director of SprintRay, the most important thing to me to this day still remains patient care. Why does all of this technology matter to the patients? We know you'll save us time. We know you'll allow us to do our job better, but what does it matter to the patients? Well, when the patient gets 2 splints, when they get 2 partial dentures, or when they lose their denture and you can immediately print them another one the same day, within hours. You offer great service and value to the patient. These are the hidden benefit that is hard to put into the paradigm chart. That is hard to calculate. Dr. Worley, Renee, and Mott Institute innovated same-day denture service for his patients. Look at how gorgeous it looks. They're the masters of characterization. I don't think I have delivered a lab-fabricated denture that looks like that. In fact, if a patient shows up to my office with a denture looks like that, I'll probably start doing perio. I can tell. Today here at Chicago Midwinter, we're announcing several new resins and some new hardwares. Hossein and Hassan has already described to you what they are and how we test them and their mechanical property. what I would like to tell you from a clinical perspective is the story of how they came to be. First up, announcing the new Apex. How many people like that presentation? All right. Now I'm going to take everyone down a notch. The story of Apex is not all flowers and butterflies. Last year, around May, SprintRay released a denture product called the High Impact Denture Base. I remember the team, Asan and Amir, they're full of excitement, and they ran out to me, and they say, Steven, we came out with this new, nearly unbreakable denture. Look at it. I looked at it, and I looked them in the eye, and I told them, it looks terrible. In fact, to this day, I go out to the executive team, and I tell them, who approved the aesthetic of the High Impact Denture Base? I would like to have a conversation with this person. When you move really fast, you don't always get things right on the first try. You don't always get to the perfection. In fact, we may never get to perfection. But the idea is that as a clinical director, as a full-time clinical dentist, I had a hard time justifying putting the highly opaque and plastic-looking denture base in the patient's mouth despite knowing how strong it is. It could be the strongest product, it could be the best engineered material, but if the aesthetic is not proper, we're not doing the patient any service. The story of Apex to me is not about how this product is so great, but how we came to this product. In May of 2023, the formulation of the high impact denture base was locked. In June of 2023, I told the team it looks horrible and will not speak on it. By August of 2023, the Biomaterial Innovation Lab have came out with and locked the resin that we call the Apex today. A high translucency, high aesthetic denture base and denture teeth. And that's what we have today. It took 3 months. The reason why we're launching it today instead of Christmas last year was because of regulatory reasons. If it wasn't for the red tapes for regulatory and manufacturing, we would have released this even sooner. I've been dentist for over 20 years. How many companies have you seen that are able to move at this pace? How many companies will own up to minor mistakes and correct it? To this day, my CEREC milling machine, the lid will break every 8 months. 18 years after its introduction, never fixed and never will. And I'm pretty sure they're proud of it. Here are some of the material that we have. Asan went over some of the material strength. Sure, we have the best in class material. Sure, we're better than resin A and resin B, but I think the important thing here is we're getting to the point for the first time we have a material that is stronger than PMMA. Higher fracture toughness, better wear. What does that mean for us? These are no longer provisionals. These are now the new standard for dentistry. We're only a few years into resin development. We're only getting started. The idea is that we are here to bring about the advancement of dentistry, not replacement of dentistry. We are not trying to 3D print something that is as strong as PMMA. We're not here to try to 3D print something that is as strong as a laboratory mill or laboratory fabricated night guards. We're trying to do something even better. We're just warming up. This is similar to having a Cybertruck that can beat a 911 on a drag race just because we can. Imagine what else we can do. While we have very beautiful computer rendering of this product, I think all of you here are more interested in what it actually looks like clinically. This is a case that we delivered just last week. I have a bad habit of never cherry picking what I present. I'll present the very last thing that I did. So this case was an immediate extraction case. We're able to scan after the extraction. Maggie was actually able to design it chairside using a completely free software. We printed the teeth separately. I believe those are actually ceramic crowns because, frankly, in my office, we're too lazy to swap out the tanks. We printed the apex base. We're able to deliver this in the patient's mouth with minimal adjustment. All of you know how long it takes to adjust a partial denture until the patient is happy with it and they leave the door. We're able to snap this in. I think we had to do a couple of adjustments on the cusp, and that was it. So this is Maggie Lim. She is my design fabrication specialist. I usually bring her to the events, but it's too far for her, and she's actually still working with my wife today. So I get this question asked me a lot. What is the single most challenging aspect of adopting 3D printing in your dental office? And I'll say the most difficult part about 3D printing currently is it's not really a plug-and-play solution. It takes time, it takes effort, and it takes expertise to be able to do this efficiently. Well, the good news is that person does not need to be you. Of all the things that I presented, over 90% of all the clinical work, over 90% of the design, the printing, the polishing, the staining and glazing was done by my design fabrication specialist. This is why I love 3D printing, because I'm just having fun. When I tell my patients that, hey, would you like to do an orthodontic aligner? Do you think me as a dentist, I'll like it if now I have to take the scan, I have to work on the software for half an hour, I have to print the model, I have to trim everything, I have to polish all of it, and I have to deliver it? No, I will not be having a good time. I, as a dentist, have important things to do. My kids like Pokemon, so I have to find out where to buy them. The next season of the Netflix is coming up. There's some shows that's leaving Paramount Plus. Those things keep me sane. And it's not that I'm lazy, but yes, I'm lazy. But that's why I'm happy. 20 years into clinical operation, I'm more excited than ever because what I do is becoming less and less. This is what I like to call, how do we do less of what we claim we love to do? And here's your solution. We talk about the Apex experience and the story of how Apex came to be. I want to bring you to a second question. What if you already have a very good product? What if you already have an industry-leading product? The NightGuard Flex is one of the most popular products in SprintRay inventory. Nearly every single dentist that owns and operates a SprintRay ecosystem are printing their NightGuards in-house, and nearly every single one of them are using the Flex. We went through the same pain that we did with Apex years ago, when the first generation of Splint was arguably terrible, and then when the material science team came out with a Splint, it was nearly universally loved. Over 90% of all dentists love this material. I can tell you nearly every single one of my patients love it with very minimal adjustment. Over 85% of them will recommend to their peers or colleagues. Those 5% that don't want to recommend is because they don't want their neighbors to get a 3D printer, so they can keep the market less competitive. So what do we do with a product like this? We have a great product. Everybody loves it. And then this is one of the highest volume selling product out there, and it's arguably the best in the industry. So the team over here at SprintRay, they cannot leave good enough, because the aspiration is always to do better. So this is what we have. So what we just showed there is not one single product, but 3 separate products that are combined into a clinical solution. Now we have a method of instantly designing your splints, print it faster than ever, and be able to cure it faster than ever. And on top of that, we have the optical polish tank. So even after you print it, you no longer need to sit there to coat it or to polish it. And I think this is an opportune moment for me to unveil. I'm a big car enthusiast, and one of my favorite cars in the world is a Nissan Skyline GTR. This bottle is called Night Guard Firm 2, and the color is midnight purple because it's my favorite color on the Nissan Skyline. Sorry, team, I did not tell you that. And there they thought I was not a nerd. FlexSplint 2 will outperform FlexSplint 1, but for those of you that love FlexSplint 1, Splint 1 will still be on the market. So we'd like to offer our users a choice. If you like the O, stay with the O. We go through the same thing with composite. We go through the same thing with our bonding system. If you like what's out there, you'll still be around. But the Flex 2 has much stronger property when it comes to elongation. It has a higher flexural modulus. And on top of that, the impact strength is better than before. But the most exciting thing of all is with the optical polish, this is what it looks like coming out of the tank. This is, again, the last patient I printed last week. So that's literally what it looks like. Here's a comparison for people that want to know what it looks like with the optical polish and without. We printed 2 of them on the FlexSplint 2. On the left-hand side is what your printer with the current tank will look like. On the right-hand side is with the optical polish. You can see the support still firmly on there. I have done nothing. In these particular cases, all I did was I took a little SprintRay snipper. I snip off all those supports carefully, and I deliver it in the patient's mouth. It's really as simple as that. It's an additional 5 to 10 minutes saving in clinical efficiency. So here's the midnight purple, my favorite color. What else do we have? Are we at the SprintRay Biomaterial Innovation Lab and at the headquarters, do we sit around and we ponder for 6 months to work on 2 products? One of the hardest thing in my position is I know all these secrets. I cannot talk about them. These products here on the table is what we're announcing today, but we'd like to, with Amir's permission, like to tease a little bit of what else is coming. Die Model 3 is coming. The sticky surface is no more. With the NanoCure, we can now print models faster than ever with a full arch kit. The surface is a lot smoother. It's more matted, it's more beautiful, it is more accurate. We came out with a material that has an elongation property, which is nearly insane. Even in filament printing and other type of 3D manufacturing technology, it's really hard to print a material that is ultra flexible, that is ultra high impact, that's very, very tear resistant. This material feels like when you're really hungry and buy a bag of chips and you cannot open it. You're sitting there struggling with it. That's what it feels like when you're trying to pull it. We're trying to figure out how to snip off the support a little bit easier, but it's an amazing material. We think this one day will be a great night guard or a sport guard. But I think the application for this material will go way beyond that. We're at a point where the innovation and the engineering goes beyond what we use clinically today. It takes a while for the brain to adjust, to replace what we know, to do what it is we know, until the day that we sit down and go, what else can we do with this? And I think that's when the breakthrough finally occurs. We understand staining and glazing is very important. The current staining and glazing solutions are not meant for 3D print prosthesis. They're not meant for resin chemistry. Here at SprintRay, we believe that the best material for staining and glazing, the best material, should be something that is made specifically for the resin they're designed to adhere to. It is not a material that you stain and glaze and you cannot cure in our cure. It's not something that peels off because they're chemically incompatible with 3D printed resin. We're hard working on this. Dr. Worley Renee is helping us test super high translucency, high ceramic content resins. So we can print it nearly clear, and it's still over 50% filled ceramic. But last but not least of all, something that both me and Maggie will appreciate tremendously. This next thing will be the big breakthrough of the year. the next generation material that will cut down our chairside workflow by leaps and bounds. No longer do we need to do thermoform. No longer do we need to do suck down and then trimming. What if we can just print it directly? What if we can combine that with the innovation of optic polished tank? The bottom one is printed on a standard tank. The top one is optic polished tank. This is what I'm most excited about. This is what I'm most invigorated about. And this is something that I can't wait to tell all of you. I took a photo of the first official prototype that we printed, and then I snatched it from Asan. This is in my hand right now. I can't wait to tell you all about it, but unfortunately, we're out of time. So with that, I'll hand this back to Amir. Our best innovation is yet to come.
Thank you, thank you. Appreciate every one of you coming over. I know you expected a party. We're really good at those parties, but this night, tonight, we hit you with science. Thank you so much. Come to our booth, visit us at the main floor. See every one of this. We have some samples here. Grab a drink on your way. Thank you again for coming here tonight.